All right, hello and welcome everyone to Differentiating Exponentials. So I had a couple questions that came through to me. And when I saw those questions, I realized they weren't particularly trick questions or even necessarily harder questions. They were just your stock standard basic differentiating exponential questions. So when these questions were given to me, that made me think, well, we might need to just quickly recover how to actually differentiate exponentials, and hopefully through that also answer those specific questions that were asked. All right, so let's get straight into it. So this is going to be a very quick, short lesson. What are we going to cover? We're going to learn how to differentiate exponentials, and specifically these are the two examples we're going to look at. All right, so on to how to differentiate exponentials. By the way, if you're not super familiar, this notation here just means differentiate with respect to x. I'm trying to think, do they abbreviate it like that? There is an abbreviation. I actually don't remember what it is. But anyway, whenever you see that ddx, what it is asking you to do is to differentiate the thing. Now, if you have some sort of exponential, right, it's not always just an e and then there's an x at the top. There may be some other sort of a function up there, but the way you differentiate it is always the same. Whatever function is up there in the exponent, all we need to do to start off with is differentiate just that part on its own. So you go ahead and you differentiate that function that's up in the exponent. So in other words, you get your f dash x. So you differentiate the function and that moves down the front. That's the tricky part of the question. And then the rest of it, well, the exponential then goes right next to it, being multiplied, completely unchanged. So to differentiate an exponential, just take the function, differentiate it, stick the differentiated part down the front, and then the exponential remains completely unchanged with a completely unchanged original function up there in the top. Just to show how that works with just a couple simple examples, let's say you're asked to differentiate the following. And I gave you this question here. Okay, here we have e to the, say, x squared. So in this case, if you wanted to differentiate e to the x squared, you take that function that's up the top, which is x squared, and the very first thing you do is just in your head differentiate that. What does x squared become? It becomes a 2x. You take that down the front, and then the exponential will remain where it is, completely unchanged. Let's just look at one more. Let's say this time we have e, and then the function at the top is, say, a 5 minus 2x. Okay, we want to differentiate this. Again, when you're differentiating exponentials, you just take that function that's at the top, 5 minus 2x, and we just need to differentiate that. You differentiate the 5, it becomes a 0. You differentiate the minus 2x to the 1, power down the front, 1 away from the power, you get a minus 2. So differentiating the function, you end up with a minus 2. That gets placed down the front. And then the exponential will remain as it is, completely unchanged after it. That's how we differentiate exponentials. So let's move on to the two questions that were asked. Okay, so we want to differentiate this expression here. It's a combination. There's an exponential term, which we can differentiate just the way that we've learnt. And there's just a normal polynomial term, which, we're just going to differentiate the way that you learnt back in prelim. So how does this work? Nice and simple. Let's differentiate the exponential. Start with a 2x and differentiate that. You get a 2. That goes down the front. the exponential remains there unchanged. Okay, so we've differentiated this part. Now let's go ahead and differentiate the x to the power of 1. Power down the front, 1 away from the power, which of course, could be rewritten as just a 1, because anything to the power of 0 is a 1. That's your answer. So that's how we differentiate that first one. And let's look at our final example that we're going to cover in this lesson. We want to differentiate this. Again, I've deliberately rewrote this question using this notation here just to try and get used to it. So d dx, that means we're differentiating, this expression of x's. We'll differentiate with respect to x. And we're differentiating this here. Right? So it's just like normal. We're just going to go ahead and differentiate. Again, we've got a mixture of polynomial terms and an exponential term, and we're just going to go through and do each one individually. So what's this thing equal to? Let's differentiate the x squared. Power down the front, 1 away from the power. I'm not going to actually put in that 1 there. The next one, again, power down the front, 1 away from the power. You end up with a 2. Again, if you haven't quite properly learnt how to, differentiate those normal polynomial terms, you do need to get really competent at that. You shouldn't be really having to do any working out when differentiating 2x. You need to get to the point where it's automatic. And for this last one here, okay, now we have the exponential. So again, what are we going to do? Well, we're just going to go ahead and start off with the function and differentiate that. So what I'm doing in my head is I'm looking at the 1 minus x and I'm differentiating it. This becomes a 0. This becomes, this becomes a minus 1. So now that we've differentiated this function at the top, it's actually a minus 1. I better change that positive to a minus. We have a minus 1, and then the exponential will be there completely unchanged. And in this particular case, there's not a whole lot of, in actual fact, there's no like terms. The only sort of simplifying I could do is maybe ignore that 1 out the front of e and just write it as a minus e to the 1 minus x. And that's it for the second question. So hopefully this made sense. Hopefully you feel a little bit better about differentiating exponentials if you were struggling with them. If you do have any further questions, you know what to do. Please let me know and I'll help you the best I can. All right, see you in the next one.